Hi guys, welcome to my channel. Today let's solve it as a lead code question. First I'd like to apologize for the delay, and the description of the question is as follows: that we were given a 2D plane where we place n stones at some integer coordinate points. Each coordinate point may have at most one stone. Okay, at most one stone in the sense one stone, or there could be no stone. So here I'll just write it as a note point, and a stone can be removed if it shares the same row or column with another stone that has not been removed. Okay, that's point is to be noted. A stone can be removed if it shares the same row or column as the other stone that has not been removed. So in that case we could remove the stone. Given an array of stones of length n, so n array of stones is of length n, where each stone represents the x coordinate and y coordinate, x and y coordinates represents the location of the ith stone. We need to return the largest possible number of stones that could be removed. So let's just consider the first example over here. The first example is given as 0 0 coordinate, followed by 0 1, followed by 1 0, followed by 1 2, followed by 2 1, followed by 2 2. So as given, I could ideally remove this 2 2 because this 2 2 is sharing the same row with this coordinate or the same column with this coordinate. So ideally I could remove this. One stone is removed, this one, and I could also remove this because this is sharing the same column with this. So this is also removed. I could also remove this because this is sharing the same row with this. So this could be removed, and 1 0 could be removed because this is sharing the same column with this 0 0. So this is also could be removed, and this also could be removed. So ideal answer would be 5. So that's how we deduce the answer. And given in a solutions, like I'll just show you the diagram in editorial for getting a clear understanding. So I just mean to say that if given these represents the coordinates of a stones, this being 2 4, right, these being the coordinates 2 4, this is being 4 4, this being 4 and again sorry, this is being 2 and 6, this is being 4 and 6. In this case, like, this is related to this is related to this, but there is no relation between this stone and this stone. But anyhow, as this is related to this, so instead of making this not connected, I'll just connect this as well, and I'll just specify that to deduce my answer, first I'll remove this stone. That won't cause any error to our answer, or that won't be any outlier. So I'll just remove this stone, and then this stone, and then this stone. In this case as well, first I'll remove this, next I'll remove this, next I'll remove this, next this, next this. Ideally, in every connected component, one stone would be remaining at the last. So that's very simple part of it. First I'll just need to create an adjacency list. I'll just call it stones.size. I'll just need to find my x and y coordinates as well. Okay. So I'll just call it vector int adj list n. So I'll just try returning -1 for now. It should be working fine. Yes, I'm getting -1. And I'll also call avoid DFS calls. I'll also just have a DFS over here. My DFS will be taking my adjacency list according with also I'll just pass this visited and current stone. uh, let's make sure that everything is working as expected. So now here for int I equal to 0, I is less than n, I plus plus. I just need to find the number of stones that are connected. So I'll just iterate into all the stones, or all the stones that's corresponding to each other to find the connected stones. I'll just say adjacency list of I. No, if my stones of I 0 is equals to stones of Z 0, if they are sharing the same row, or stones of 0 I equal to stones of 0 Z, in this case they are sharing same row. In this case they are sharing the same column, because IJ would be different. And no, just a second, what would I get data from 0th coordinate? That's x value. So I'm just checking if both of them are having same x value or both of them are having same y value. This shouldn't be I0. Yes, that's where the confusion arises. This should be I1. I'm sorry for that. I'm not sure why I written 0. Because ideally I need to check for both x and y coordinates. Then it should be 1. I'm sorry. So adjacency list of I dot pushback z, and ADG list of z dot pushback I. So that's how it works. I'll also call vector bool visited n false, where n is my stones dot size. I'll just call int connected components to be 0. For int I equal to 0, I is less than n, I plus plus. I'll just check if visited of I, if I is not visited. In that case I'll just call DFS ADJ list visited and stone being I, and connected components to be plus equal to 1. If negation of visited stone, I'll just make visited stone to be true. And for auto neighbor in ADJ list of stone, I'll just call DFS ADJ list visited neighbor, and I'll just return n minus connected components. So it's working fine. Let me just submit this out. Yes, it's working as expected. To fairly reduce the complexity of it, I will just specify my C++ compiler not to use any headers from C. That will be useful for taking input or giving output. So I'll just call cin.tie to be null. Similarly, cout.tie also to be null. I'll just submit this now. Yes, it's working fine. So feel free to add anything in the comment section if you think anything is unclear. Thank you.